In this session, my plan is to introduce you Python machine learning library and how Python could be used to use for machine learning. Very briefly, I'm going to discuss. And the exercise that we are going to do this one on 3 flowers, and we will have a data set, and then we discuss how we can load the data set, which means we can get used to this, and then we also discuss the visualization bit. First of all, just taking 2 attributes at a time, and then also we will improve the visualization by looking at all the 3 different types of flowers, right? Then we will look at dividing the data sets. I will discuss why we need to divide, and creating a model or machine learning algorithm used to create a model to recognize these flowers, right? And then we will discuss how we can visualize the model, and then the accuracies, because we need to apply this model for new flowers. We want to categorize into previous 3 categories. So we will discuss how you could do that. Now for that, we will look at how accurate our model for new data, right? And then we discuss a little bit about some matrices, and finally, right. So I forgot to switch on my mic. So let me briefly go through. So the plan actually is to discuss how we may use machine learning in Python, right? I hope by now everyone finishes this, so we can talk about this. So this is the what I'm going to discuss throughout the today's session. Visualization I will discuss a bit, then improving the basic visualization, dividing data, I will discuss why we need to divide, and then building a machine learning model, right? We discuss how this algorithm could be used to predict a type of flower, so that I'm going to briefly discuss about it, and then display the outcome of the algorithm, and also we look at how you can actually make predictions, right? So that's what I'm going to do. But before that, I think you have to have some idea about machine learning. Can you all yeah, hands down please. I'm going to ask, and I want you to raise your hand if you know what machine learning is. If you are familiar with the term machine learning, can you please raise your hands? You can keep raising your hands. And if you are new to machine learning, those who already know machine learning, right? Okay, Kasun, can you tell us how depth you know about machine learning, and do you use machine learning in day-to-day work?
Yes, I use for predicting some values.
Okay, so you were using from the beginning the Python as well as these libraries for prediction, or are you using a different technology stack?
I am using Python.
Okay, so I think what I'm going to teach then, I think quite familiar to you, Kasun. Nothing new, I guess, right? Okay, others I think it's new. So let me start with a small presentation on especially in data analytics, as well as few basics that you need to know before we go into look at the implementation details in Python. Right. Okay, first of all, right, can you see my presentation?
Yes.
Yeah, okay, right. So this is actually very uh, basic introduction. For a machine learning course in Python, I think you have to spend at least 10, 15 sessions to, get a good understanding of what machine learning is capable of. But since this is actually an introduction so I will try to cover the basics. Right. First of all, there are different types of learning available. What do you mean by different types of learning? Now we know that computers can be used to learn some tasks, right? So, so the algorithm that we can actually use for this is normally known as learning algorithms. So first of all, let's look at some basic types available, and then I'm going to focus only one. The very common type of learning is called classification. Like given a weather prediction problem, we need to identify what will be the weather condition, for example, tomorrow, right? So basically, that could be a particular value that you are going to predict, maybe a type, maybe sunny, overcast, or rainy, something like that. If you look at the outlook, so similarly, you can actually decide a particular label, right? So the example that you have seen earlier with the three flowers is a classification problem. And another one would be like getting a patient, whether predicting whether a particular person is having a cancer or not. It's a classification problem. So that is actually quite commonly used in this area. And then another type of learning is called association learning. Now things like when you go shopping, for example, you tend to buy some items together. So if you are interested on learning this, then you have to apply association learning. Now, for example, when you purchase something on the web, let me say eBay or like Amazon or some, then they were suggesting some other items based on your previous purchases. So this is actually called association learning, right? So sometimes we need to know that, right? Then clustering. Clustering means we look at similar groupings. Now, in your case, you have customers. There are some, profitable customers. If you work in dialogue, you know that some are really used in the system. So profitable customers. So sometimes we need to identify these customer groupings. So if you want to group your data points, then we have to apply the learning called clustering. And another one is called numerical prediction. Now it's similar to classification, but classification is a label, like the type of flower, like whether you are having a cancer or not. In numerical prediction, you are having a some value. Okay, what is uh, the share value tomorrow, for example, right? You're particular predicting share value of a particular share. So similarly, so these are like we know normally as basic types of learning. So we have algorithms developed for all these types of learning. I told you like this is a vast area, so today I'm going to focus on classification problem, and I will demonstrate and briefly discuss the implementation of classification problem in Python. But before we know about the classification, we should first know like what classification is. Like I said, if you have a weather data set and if you want to decide whether you are going to play or not a particular game based on weather condition. So it will be an example for classification learning. So this is known as supervised learning because When we collect the data, we have to collect the data with this label. Now, for example, in this particular problem, when we collect the weather information, we have to collect the information about whether you are going to play that game or not. Similarly, cancer prediction problem, you have to get all the demographic information, test details about the patient, and then you need to know whether the person is having a cancer or not. In telecommunication data, sometimes we want to identify those the customers who are going to going out from the system, right? Maybe for other partners we will normally call churn prediction. So we want to have a data set. We will have those who are retaining in your system and those who have left your service, right? So that we will have to collect this information. Since this data we provide with the actual outcome, we call this as a supervised learning problem. So the outcome usually normally we will say class, right? So this whether you are going to play that particular game is or not, we call it a class, right? Okay, now once you have the data, this is history, isn't it? Now how can you use history to predict the future, right? Some usually say in some history repeats. So similarly, what has happened in the historical patterns may emerge in the future as well. So how do you measure that? So measure that we have to measure based on new or fresh data. Fresh data means you don't know the outcome. Now, for example, tomorrow's weather we don't know now. So we can use an algorithm to predict tomorrow's weather, but when we reach tomorrow, we know what the actual value is. So likewise, you can collect information. In telecommunication data, you can predict whether a particular customer is going to churn from your system, like maybe like next month. So by next month, you know whether really he has churned from your system or not, right? So that we can actually use fresh data. Later on, the outcome we can use as a data set, right? Now, normally when you want to apply these problems, we have to have a single data file. Okay, why I said this? Normally, if you know the databases, usually customer demographic data, his background details are in a separate table, and his telecommunication call details are in another table, and so on. But if you want to use machine learning, then you have to what we call denormalize. You have to put into one single file. There are some research going on how you may learn when you have data in separate files, but generally we have to have a single file. So if you have like data warehousing tools, if you are using, whenever you want to analyze some data, you have to find or you have to create one single flat file. So remember that, it's very important. Then when you collect the data set, usually we will have rows and columns, and usually columns we have what we call the attributes. So what's an attribute, right? So attribute, simply we can say it's a set of features, right? Or maybe you can have a flag, right? And then sometimes these attributes may depend on one another, right? But this is useful. Then there are different types, like nominal means you have a numerical value, right? You have a numerical value. And nominal means you have categorical values like labels. For example, temperature in a nominal scale we can say high and low. So ordinal means you have an order. When we say high and low, you can define the order. Or if you take a person's grade A, B, C, D, there's an order. So some you can find an order. So in some cases you can have intervals and some cases you have ratios. So there are different types of attributes available. But remember, mainly in machine learning, we usually use only two, mainly, right? That means we will use either categorical or nominal, or we will use numerical, right? Usually we will handle these two. Okay, so that's about the attributes that we will use, right? So when you're preparing the data, when you get the data, right, you have to be very careful. As I told you earlier, data might come from different sources, different departments. So for example, same name can be written in multiple ways. So all these things you have to correct before you apply any machine learning algorithm, right? So usually the practice is we will have a data warehouse tool set where you will use this tool set to combine your data, and then you will start with a flat file, right? So critically you can need to think about the type as well as the level of data aggregation, which means whether you are going to use the values, actual values, or it's you go to use average value per month, average values for quarter, average values for years, and so on, right? So that's when you're preparing. And sometimes if the data is not available or data missing, sometimes you have to fill the data. So the data preparation is most important part in data analytics. Right. Now that we have learned this, let me show you a very simple toy problem. I'm going to use this toy problem to explain two things. One about the dataset, second about the machine learning algorithm, right? So in this dataset, actually this is a toy dataset used in textbook to introduce this machine learning area, and this dataset is actually known as a weather dataset. And what you see here is set of attributes. We call it outlook, temperature, humidity, and windy. So these are the attribute. And the final one is called play, meaning whether to play a particular game or not, right? So this is called class attribute. So whenever you collect data, so you have to collect the attributes together with the class attribute. And when you take particular instance or a record will indicate one instance, like when outlook is sunny, temperature is hot, humidity is high, windy, false, then you are not going to play. So similarly, data might have like numerical quantities as well, but at the end, in classification learning, you have to have a class attribute. Right. Before we move any further, any questions up to this point? So if you already have worked with the data, I hope you have some idea what you could do with the data sets. Right. Okay. So let's move on. Now, first of all, once you collect the data, before we apply any machine learning algorithm, you should visualize and see, right? Now, for example, if you have a categorical values, you get the histograms and how frequent particular value appears or not. So that simple visualization could be used to make the initial guessing, right? And you can use either two-dimensional or three-dimensional to see any dependencies. So those who already work in machine learning, you first of all look at the dependencies, right? And this level, if you are not an expert in the data that you handle, you should consult any domain expert, because sometimes, for example, if you are trying to predict whether the person is having a cancer or not, we have to have some medical domain expert. Sometimes they know what to look for, right? And then sometimes you have a lot of data. Nowadays we talk about big data analytics. Millions of record. I think telecommunication industry, that is one of the problems you have. Okay, the answer is simple. You take a sample data to analyze, right? So this is again things you need to remember when you are getting to know the data. Right. Okay. Now there are many machine learning algorithms available, right? Starting from simple majority classifier, or we sometimes say 1R algorithm. There are very simple algorithms. We have rules, decision rules. We have decision trees, and nowadays we even have deep neural networks. If you heard the name, there are very complex algorithms available. For example, if you have image data or voice data or a video data, people now working on deep neural networks, which is very complex algorithm. But normally, generally, in this area, we always recommend to start with simple algorithms, right? Because simple algorithms, often people have shown that they often works well, right? And then if you can find a solution with a simple algorithm, then you can easily understand what is going on, right? For example, in neural network, it's very hard to explain why the outcome you get like this. But simple structures, we can normally identify the decision in structure. This is very, very important. Now, for example, in banking industry, sometimes we can use machine learning to decide whether to offer a loan or not. When customer applies for a loan in a bank can, based on their historical data, they can come up with an automated system to decide whether to offer or grant that particular loan. But let's say you are going to reject the loan. When you are going to decline the request, then you have to explain it. So since you are in the service industry, you know how difficult sometimes to handle customers. So you have to explain why they are rejected. So it's not only to make the decision, sometimes your cause is very important. In medical domain, for example, if you look at when doctor decide a person having a cancer, then you should be able to diagnose the reason for that. Now there's the same thing comes with the algorithms as well. So the success of the method, I said there are many methods, is depend on the domain. So I told you already, deep neural networks are now extensively used in image domain, and then also like videos, voices, voice recognition, and so on. But then there are some other algorithms which suited for other domains, like naive Bayes classifier is quite commonly used in text classification problem, right? So that actually comes with the practice. You need to learn a lot of algorithms. You have to apply it. Then once you get master, you know that which one to use and when. Okay, but always start simple. So that's what I want to emphasize here. Right, as I told you, like there are many algorithms available, like decision rules, decision trees, nearest neighbor algorithm, naive Bayes, right? And then if you look at ensemble, we have we have support vector machines. Then we have ensemble like rotational forest, random forest, and quite commonly nowadays we use XGBoost, right? So these are like lot of algorithms. But since this is just an introduction to these algorithms, I'm going to introduce you decision tree machine learning algorithm, right? So let me explain what a decision tree is, and then I'm going to briefly discuss how the algorithm is used to automatically build a tree from data. We are not going to do it manually. Now usually when we write programs, we have to manually make the decisions. But here what you will see is we provide the data, An algorithm come up with a model, right? So let me explain what decision tree model is, right? Now, if you look at these decision tree algorithms, and if you look at how they created a tree out of this data, they use different techniques, but one is the common one is called divide and conquer. Now, one idea is divide and conquer means when you have a bigger problem, usually you will break into smaller problems and then you try to solve it, right? So in that sense, usually when you want to create a tree, you try to identify attribute to put in the root in the decision tree and then try to make branches. And you are trying to, repeat this in each of these branches until you find a stopping, right? Or you have to say that, okay, that's the end of the decision tree, right? So let me show this graphically. Now let's say this is my data set, right? And what we are going to discuss is actually come up with something like this. Now from the data, this is the weather data, we need to predict a play attribute based on these combination of attribute values. Now when you say attribute values, now this is the final one we look like. So what you see here is called nodes. So the nodes are the attributes. So we have outlook, we have humidity, we have windy. And branches are for their values. So outlook we have three different values: sunny, overcast and rainy. Similarly humidity we have high and normal, right? And at the end we have the classification, right? This yes and no means the play attribute. So this means something like this: when the outlook is overcast, then you can play the game. When outlook is sunny and humidity is high, then you are not going to play the game. So you see the decision structure here. Okay, any question on this, please, before we move on?
Is it like flowchart?
Yeah, it's like a flow chart. Yes, you can think like that. But you see, we are not going to create this flow chart. Our program will give us this flow chart. What we input is the data. Flow charts usually we create manually, no? But here we get this tree, this structure from the data. So when you change the data, you get different different decision trees. You got my point? Right. Okay. So let's see how they do this. Now when we have a data set like this, first of all we have 4 attributes and we have to make a decision which one to put at the top of the tree. Right? Top of the tree, which we call root node. Right? Now here are the attributes, and then there are 3 values. For example, let's take outlook, sunny, overcast, rainy. We have 3 different values. So that's why in outlook we have 3 branches like this. And these labels based on the outcome. So we know that this is the outcome. So when outlook is sunny, we know play is no. Sunny, play is no. Sunny, play is no. Sunny, play is yes. Sunny, play is yes. So which means when outlook is sunny, there are 3 no's, 2 yes. So likewise for each of these branch values, attribute values, we have identified their class values. Now we have 4 attributes. Now to create a decision tree from this, we have to decide. Now decision tree is something like a tree. You put a root node and then you make the branches. Now question is which attribute I should put as the root node. Can you think of something? Which one do you think is best? In what sense? Yeah, you can make a mistake. Just can you tell me, try to give me a suggestion. Which one I should select to put it the top node? It's very important.
Minimum class variations.
Okay, good point. Yes, minimum class variations. Now, for example, if I related to that, now the classes for, if you look at attribute values, and here we have two different classes. Here we will have only one class. Again, we have both classes, right? So likewise, if you look at in, sometimes we call purity, pure separation of class values. Yes, we can say that Outlook is best, right? So actually, there are many ways to create decision trees. One thing is, like you said, minimum class variation, where we can look for pure classes. So when you look for pure classes, you can see this is everything is yes. That means we can finish this branch at this point, because since everything is yes, we don't have to put any other attribute, right? But here it's not like that. So likewise, we can select Outlook. Now if you select Outlook, then this branch we have to select another attribute, isn't it? Why? We have both the classes, we have to pure separate this one. So here is how, when we select Outlook, these are the three other attributes we put. So after Outlook we put temperature, windy and humidity. Now according to what we have said earlier, when we look at pure classes, which attribute you think is best? Is it temperature, humidity or windy? So here, for example, when you have Outlook sunny, when you put temperature, we have three different values. This is how the class separation. When you use windy, this is how the class separation. When you put humidity, this is how the class separation. Which one do you think is the best?
Humidity.
Yes, in this particular case, if you are assuming that it's a class variation, we can think that this is the best one. Okay, now we have Outlook and humidity, right? And the middle one, everything is yes. So that is also end, yes. And then we have to find another attribute to put it here. Now we are left with temperature and windy, right? So we can put either temperature and windy. So when you do so, you see when you put windy, it has the pure separation. So that's why we end up with this decision tree. So what it means, based on our data set, we can come up with this model, right? Now let's say we have a new, right? So this is my decision tree model. So this is the tree. Now when you get the new data point, let's say Outlook is overcast. We have overcast, Outlook is overcast. Then humidity is normal, right? Then temperature is high, wind is yes. We don't know what play is. How do you find play? It says Outlook is overcast. Yes. What is the play attribute? Is it yes or is it no? I will repeat the question. Now let's say we have a new situation. In the new situation, we have outlook is overcast, humidity is normal, right? Temperature is high, wind is, let's say, just means true. Wind is true. My question is, should we play the game or not? We need to play the game. How? When you go through the outlook overcast, then you don't have to check all the others, because when you say outlook overcast, it's always you can play the game. So you see that in classification problem, what we do use in the data set, we build this model, and then later when we get new data points, using the model, we can predict the situation. This is the idea that people have actually used in most of the cases. You use a training, we call this as a training data set. You use a data set to create this model, and based on the model, you can make decisions. Any questions? Right. Now, let me talk different issues. Now, which one is the best attribute is what we need to ask for decision trees. So there could be many ways to do this, but one way is use of purest nodes. So then, now computer to decide this, you can't do the way we did like this. So best way would be they can come up with some mathematical way to representation this one. So for example, the technique that I have discussed can be used to calculate using information gain. It's actually coming from information theory. So basically we have formula to calculate the information before the you make the branch, right? So before and after you check the information. So I'm not going to go into detail how exactly it works, but basically they are mathematical formulas where you can implement in Python, for example, or any other programming language, and these could be used computer to decide which attribute to use. So there are many measurements we use. We use information gain and gain ratio and Gini index. So all these three use different ways to select the attributes, right? And I will show you in, for example, in decision tree algorithm how we could change this, right? So that part I will do. Right. Okay. Now the second one that now, first of all, are you clear about the classification learning? Do you have any questions on that one? You are clear about classification learning? Right. Second question, are you clear about the decision tree algorithm? Like I have briefly discussed how you may come up with a decision tree based on a data set. So that is exactly what I am going to demonstrate next. But before that, we want to know how well our model will work for new data, right? So this is exactly what we are trying to do with the evaluation. How good our model is, because we will use historical data to predict the future, right? So there are techniques that people use is to do this. Now usually when we try to evaluate, meaning like you measure the success on new, on future, in future, so we can divide data. the common way to do this is you can divide dataset as training and testing. That means part of the data we will use to build the model, part of the data we will use to evaluate, meaning we look at with how accurate the models are. Right? This is called evaluation. And there are issues, right? There are many measurements people came up with, and different scenarios we had to use different measurements, but classification accuracy is the simplest one we can think of. So I'm going to explain how we can find classification accuracy based on this data. Then we can also look at, you can change the evaluation based on large data set or medium, or when you have a small data set. If you have enough data, usually we divide the data set as 2/3 for training and 1/3 for testing. That means we divide, let's say you have 300 data points, then we will take 200 data points to training, which means we build the model, and the remaining 100 we can check how accurate they are using that model, right? So that's what we say, training and testing, right? And that's one way to do this. So this graph shows you how the process works. So usually we get the data and we put it to one single flat file. So let's assume that we have positive and negative as the class attribute. Now create a model. In our case, we are going to create a decision tree. We will divide the data set as training set and test set. We said 2/3 we will allocate for training, 1/3 for testing. And once you build the model, using the test data set, we can evaluate, we can see the performance. Because here also we know the labels, and once you put this to model, you get the outcome, you can compare the two, and then you can see how accurate your model is. So usually this is what we try to do in machine learning. So whenever you have a problem, you identify evaluation strategy, and then you select a machine learning algorithm. You build the algorithm using training data, right, and evaluate based on test data. So the best model you can decide based on evaluation metric, or for example accuracy, right? And then there are some parameters. Parameters means in each algorithm there are things that you have to optimize. For example, decision tree, we can decide whether you need a simpler decision tree or whether you need a complex decision tree. Now if you want to do some tuning like that, then your data set should be divided into 3 parts. One is for training, one is for validation, we call it. That validation is to determine the parameters, and finally the test data, right? But if you have like using all the data as much as possible, right, we usually, once you finish the evaluation, you combine all the data to build the final classifier. So that part also I will explain when I'm implementing, right? Okay. One more thing before we move on. So when you have a third data set for validation, so you have to model train twice. First of all, you use training and validation set to optimize your algorithm. Optimize means finding correct, parameters. Once you do that, you can use both training and validation to build final model. Once you have the final model, using the test data set, you can find the final evaluation. So this is how we will use 3 data sets. Right. There's another way that we can build the models. The last one is called cross-validation. When you don't have enough data points, like cancer patients. So when you want to learn cancer patient, usually you will have very limited data. Let's say 100 data points. Right? When you say 100 data points, it's not enough. So instead of divide the dataset as training and testing, we divide into multiple partitions. We call folds. The idea there in cross-validation is you are going to maximally use your data. Right. So this is how it will work. So your data break into set of groups, and then you mark one data set as a test, and the remaining is used to build the model. Right? It's like, let's say now here we have 5 data folds, one taken as a test, remaining we use to build the decision tree. So you can repeat the process by changing the test set. So that means you can, next time, you can take the second one as the test data set. Right? Remaining can be taken for the training. So that means you can build 5 decision trees and then you can get the average accuracy. So this is actually can be used to small to medium data sets, which takes maximum out of the data. Right. So these are the terminology actually what we need to know. And finally, when you want to compare, especially when you have many algorithms, we need to decide which one is the best one. And I told you like this selection is domain dependent, right? So usually people can use cross-validation, which maximum use of data, right? But variance might be a problem. So if you want, you can repeat tenfold, let's say 10 times, right? So that is how usually we use that. Right. Final one. So when we have these predictions, we have different types of errors. Right? So one side we will say our actual class is yes and no. And our model, the decision tree for example, can make the prediction yes and no. If our actual class matches with the prediction, we can say it's a true positive. Our actual class no matches with the predicted no, we can say it's a true negative. Then other two are the misclassifications. And usually what we try to do is we are trying to minimize these errors. Right? But the type of errors is very important. So when you want to decide which one to use, you can look for all the measurements. There are many like accuracy, like recall. I'm not going to discuss in detail, right? But you can look at everything. So for example, these are some of the measures where we have 4 algorithms, their performance. So normally we say, okay, you better look for all the measures and then you can actually make a decision. Right. I think I have taken a lot and I actually talk about almost everything you need to know. Right. Maybe I confuse you too much. Right. Before I show you the coding, any questions from what I have covered so far? Right. Okay. I think then let's start with the demonstration. First of all, I will share my code because we might not have time to type everything because there are some places. I will download this as a Python file and then I will put it into the right? Right. So I will upload this in the Google Classroom so that you can get it from there. So I will go and upload this one, my Python file. So you can actually extract the code from this, right? So please download this and get ready, right? I'll go one by one explaining the steps. If you finish downloading, please raise your hands. Right. Right. Let me explain the classification problem. You can raise your hands while I'm explaining the basics. So in this one, we are going to look at a classification problem of classifying 3 different types of flowers, which we call iris flower. So the data set consists of 150 samples, the data points, 3 labels, class labels, that means indicating 3 different types, and 4 features, right, which actually measure these flower dimensions, right? Okay, so the remaining I will use a new notebook to explain. Right, the first one that I am going to do is the loading dataset. Last time we did this ML. Let me say, okay, I will create a new notebook. ML group 2. I'm going to put this, right. Right. First of all, I'm going to use 3 packages, modules for this. I will run, that is my first part. First one is numerical Python, scikit-learn. Here actually I'm first of all going to get the data, and the third one I'm going to use for plotting, right? Okay, that is the first part, right? Secondly, I'm going to load the data set. Now the data set coming from here, the scikit-learn, they have their own data set. Last time I showed you, right? So let me open the iris data set, and if you print iris, you can see our data set, right? Were you able to download the data? Amila, were you able to get the code? Okay, no, it's okay. You don't have to raise your hands. If you have done it, okay. Yeah. So I'm assuming that everyone has the code with you, because there's no point spending time, but I will briefly explain the points that I have highlighted in my theory part, right? Right, now you can see the data set here, and this is normally like a dictionary, right? If you remember the dictionaries, we have a key and a value pair. So the data consists of this, and then if you go down, target is the labels, and there are target names and so on. So some information about the data. Right. The next what I'm going to do, I'm going to divide the data set. Sorry, not the data set. First of all, I will get data and targets. The target means class label separately. So my capital X means the data set. We have 4 features, 150 data points. The target means our class labels, the 3 types of flowers, Setosa, Vesicolor and Virginica. So these are the targets. So if you want, you can look for x.shape will give you the details. Print y.shape will give you the details. So you see that we have 150 data points in the dataset, 4 features, and the target meaning class label, we have 150 data points. Right? If you are interested, you can just print y now. You can see the class labels. The first 50, 0 indicate in the first class, 1 indicate in the second class, 2 indicate in the third class, right? So that's the data set. Right. Now I'm going to make a plotting the data points, but you know that we have 4 features. We know that we cannot make 2D plot. We need only 2 features, isn't it? So for the plotting, I'm going to get, right, to plot, I'm going to get 2 values, right? So if you remember this notation which we have discussed earlier, I'm going to get all the rows, that means 150 data points. When we have columns, I'm getting the first column and the third column. First column and the third column. The reason is this is the 2 we can use to see the separation. So that we already know, right? So we will get this. Then we can make the plotting. So the plotting command we have discussed last time, plot command, and this is the one feature, this is the other feature, right? And then we use red color and the circles to represent our plotting. So now you can see data points like this. So x direction, we have the third feature. Y direction, right, we have first feature, right? Now the next one is I want to color different classes. So the trick that I'm going to use is I'm going to separate data points, right? So what I want to know is our target value should be 0 for the first class, isn't it? Target value should be 0. Then my target value should be 1 for the second class. Then my target value should be 2 for the third class, right? So let me show you how I'm going to do this. So when you are plotting, you are not going to plot everything, right? Earlier we used to say x and y. Now in xplot, right? So I'm going to say that I'm actually going to select only the class from 0, only set of point, right? Let me run this, right? You see that this is only one class. Similarly, I'm going to use the same code, but this time, right, I'm going to copy this same code, but class I'm going to say 1. This is the second class. This is also, I'm going to say 1. I'm going to change the color to green. Right, now I plot two classes. You can see, so this is the first class in red color, this is second class in green color. Similarly, I will plot the third class like this, right? In this one, I'm going to say it's blue, right? So what I did is, from the previous one, we have taken the class labels. If it is 0, we will use red color. If it is 1, we use green color. If it is 2, we use blue color, right? Then I can put the other information, right? So let me put other information, right? So now other information means the two attribute I have used for this plotting, petal length and sepal length, and these are the classes. You can see, you can separate, isn't it? Right. Now let me show you how machine learning can be used for this one. Right. Now first of all, we have to divide the data set. Remember I told you the division, right? So in scikit-learn, we have a model selection, we have training and test separation. So I will show you first how we are going to do this. Right. So the code is like this. We'll use train test split from scikit-learn model selection. We divide the dataset. We have data X, label Y, and we specify the test set size 0.33. Now 0.33 means approximately 1/3, right? So when you say 1/3, so we are going to get 4 data splits: training, X-train, X-test, that means data sets, then Y-train, Y-test, the labels, right? So you can see the label sizes as well. We have 150 data points and we should get 150 for training and testing. So now you can see our training set is 100 data points, right? Test data 50 data points, right? Now decision tree model. Again, in scikit-learn, we have methods to create decision trees, right? So in scikit-learn, we have to use tree module, and then we select the classifier, right? We are going to select decision tree classifier. So there are many other algorithms, but I told you, like for this one, we have selected the decision tree classifier. Now we need to train the model, right? This is the classifier we have selected, then we train the model, right? This is the training. We have to select, sorry, right? So training happens like this. We use the fit function, fit method, we will get training and Y training. This will create a decision tree classifier, right? Now once we have the classifier, we want to know how accurate those are, right? Now for that, what we are going to do, I'm going to use the classifier to make the predictions, right? So let me first do this. We'll build the tree, but unfortunately you cannot see this. This is what we need to output. You cannot see this, right? Now for that, actually you can use another code for this, and then you have to use things to visualize this, right? Which I might not have time to show you, but let me show from my previous run. So once you have the decision tree, right? Once you build the model and once you train the classifier, you can use this code to display the model, which will display the decision tree. And decision tree looks like this. Now you see in the top root node, it says petal width. If it is less than or equal to 0.75, because this is a numerical data. If it is less than this true, then you are going to say class is Setosa. So you see that we got this model using the dataset. Now we can use this to make the predictions, right? So this is the model. I'm not going to go into details, but I think you got some idea how we did it. Now, when you want to make predictions, we can use how our model predicts and what the actual value. So for that, we have to use classifier predict x test. Then these are the predictions. Predictions means our test set. When you apply the test set to this decision tree, these are the outcomes. And we know that we know already these values. This is actual, right? So these are the two values. So now, how do you know how accurate these are? So basically, we can compare these when this match. For example, the first one prediction is 1, actual label is also 1. So it's a correct prediction, right? There could be some misclassification as well. If you go through this, you can find out in some places you might get different outcome, right? Now, for example, here the prediction is 2, but the actual value is 1. So this is a misclassification. So when you look at the accuracy using this code in scikit-learn metrics, we can get the accuracy. So it says it's 94% accurate, which is actually quite high accuracy. And then remember, we can look at the details as well. Remember, I told you like correct classifications and the misclassifications. So usually this will indicate the 3 classes. The diagonal item means the correct classification. Off diagonal means misclassification. Right. Now what we normally do is we follow this, the same thing with different classifiers. Now right now what we use is the decision tree model. Similarly, nearest neighbor is another algorithm. So you have to write the code for that. You have to follow the same procedure to find out how accurate the model is. If you can get a better accuracy, maybe you can think of, okay, that is the best one to implement, right? So that is basically what we do. But as you can see, to use the final model, you have to use full data set. Now, right now, the model that we have developed is using only the training data. My final model, to create the final model to predict actual new data, so we can use all the data available. So finally, what you see here is the final model where I use all the data to create the model. And this model, the final model, can be used, right, for new data. So this is what we can use. So you can see that I have briefly discussed what machine learning is and machine learning coding in Python, right? And remember that the course training is not focusing on machine learning, but we wanted to cover the basics in Python so that you can pursue the machine learning area. Now you are ready with the tool set, the environment. I guess you have the exposure. So I think you can now start learning on machine learning. So there are plenty of courses available. There are books which I can recommend you. And also I put this in the class room as well. And if time permits, or if the dialogue wishes to have another machine learning class, we can go very slowly, because although I have done in a few minutes, usually I use a whole 3 credit course in the university to explain this process. So if you do not get everything, it's not a surprise, because we cannot cover everything, but I try to give you the basic idea which we can use in machine learning, right? I think with that we can conclude the session. I hope you have learned Python, the basics, and also like you are now get ready to explore more in machine learning. Right, so that's all from my side. So hope to see you guys in maybe another session or something. Let's see. Hopefully we can see again. Right. Anything that you want to clarify? I took 2 more minutes more, but I think you are okay with it.
Sir, if you have time, can you give us a brief introduction about sci-fi, about statistics and optimization library?
Yeah, so that I will direct you. I have done some courses in the university. If I share those links with you, is it okay, Naim?
Okay, sir.
Yeah.
Okay.
So for example, I have my YouTube channel where I used to host this one. So in the university, normally we will also talk a lot on numerical algebra stuff, where we use Python a lot. So those videos also are there. So, but anyway, I will direct you some links in the Google Classroom so that you can follow it up. But always you are welcome to come up with the questions. So when the time permits, I will try my best to answer your queries. Okay then, if you have not any other comments, let's finish. Good luck. I hope you have enjoyed the training session and also started a new direction if you are new to this area. It's really hot topic nowadays. So I hope that you can spend time, precious time on this area. Thanks then. Hope to see you sometime. Right. Thanks. I enjoyed the class a lot.
Thank you very much, sir.
Thank you, sir.
Thank you.